Now we're going to try to graph these functions if we're given the equation as opposed to given a situation like we had before. So let's take a look at this equation right here, y equals 1 over x. Now we haven't dealt with these before, so we don't really know what they look like yet. So let's refer back to an xy table to try to get some coordinates and know what these even look like. So if I take a -2 and I plug that into my function, I'm going to get 1 over -2, or -1/2. -1, I end up getting 1 over -1, which would then just be a -1. If I try plugging a 0 into here, I get 1 over 0, which I can't do, so I'm going to call that undefined. We can't take numbers and divide them by 0. It doesn't work. If I take the 1 or the 2 and plug them in, I end up getting 1 over 1, which is +1, and then a 1 over 2. So let's go ahead and take these coordinates, the -2, -1/2, and so on, and try to put them onto a coordinate system to see what this is going to look like. So the -2, if I come left 2 and down 1/2, that's going to put me right there. Left 1 and down 1 would put me a little bit lower. Undefined at 0, so I can't do anything at 0 yet. At +1, I'm going to be 1, so I'm going to go right 1 and up 1, and then right 2 and up 1/2 for that last point. Now, we can kind of see what's going on. Let's plug in a couple more points just to see what happens. Let me plug in a -1/2. If I take a 1 and divide it by a -1/2, I end up getting -2. So if I go left 1/2 and down 2, that's going to put me about right there. Then we start to see a little bit more of a curve happening there. And if I go the opposite way and plug in a +1/2, 1 divided by +1/2 gives me a +2. So right 1/2 and up 2 is going to put me about right there. And if we were to continue to plug in points going further left or further right, we'd start to see a graph that resembles this here, that approaches the y-axis and approaches the x-axis, going in both directions. But it's never going to touch either one of them. It's just going to get closer and closer and closer to that x and that y-axis. So as it approaches those, it's going to approach what we call a vertical and a horizontal asymptote. So these are lines, these dotted lines that I've just drawn in, represent those two asymptotes. So the vertical asymptote here, or what we're going to, is x equals 0. That's the location of where this boundary line is. So we're going to get closer and closer to that boundary line, but as we get closer to that 0 point, we get closer to an undefined value, because we can't divide by 0. Or if we go out far to the right or far to the left, the larger values that we plug in for x, the smaller this fraction is going to be, but it's never going to quite hit 0. We're going to get closer and closer on both sides, but we're never going to quite get there. So this horizontal asymptote, or what we're going to abbreviate as HA, would be the y value equal to 0. So this would be our basic rational function, our 1 over x, that we can then use to transform left to right, up and down, reflect it, stretch it, and do all the transformations that we've done with the other functions. But in order to do that, we need to know what this basic shape looks like, and now we have that basic shape.